Today I'm going to show you the Titer determination of the volumetric Karl-Fischer titration. This is important because the concentration of our reagents may change over time, and to receive right results we have to determine the Titer. I'm going to show you how to do it in a few steps afterwards. My name is Ayla Reuss, I'm a lab scientist. First thing I do is pick all the stuff I need for the Titer determination, which is a liquid water standard, 1%, which is easy to use and has a high accuracy. But you also could use pure water as a standard. In this case, you have to weigh in very small amounts, which makes it hard to handle, and also the weighing error is quite big. The other option is to use a solid standard, the sodium titrate dihydrate, which has a very high water content but a limited solubility in our solvent. Then a syringe with the needle in the right size, an ampoule opener to open the ampoule safely, a waste beaker, and a tissue to wipe off the last droplet of the needle. To open the ampoule, we have to find the blue spot and then break it away from the blue spot. And for our safety, we apply an ampoule opener, which also has a spot on it, which we apply on the blue spot on the ampoule. And then we're going to break it. To prepare the syringe with the standard, we have to first rinse the syringe. Therefore, we pull up 1 milliliter of our water standard 1%, and then we pull up the rest of the syringe with air and shake it a little bit to get all the water from the syringe out. And then we put that 1 milliliter in the waste, and we repeat this again to rinse the syringe again. We pull up about 1 milliliter again and then shake it again to get the water from the syringe out. Put it in the waste. After this, we pull up the rest of the ampoule into the syringe. And in the end, we also pull up a little bit of air to make sure that there is no liquid in the needle. Afterwards, we wipe the needle to make sure that there is no liquid on the outside. You cannot use the leftover in an ampoule again because the water content will change, and that's why we throw it away. The titration cell is never really tight, that's why we have a drift. And the drift shows us the amount of water which comes from the environment into our titration cell. The drift should be below 20 microliter per minute and stable. If additional solvent is needed for a sample, make sure to perform the Titer determination in the solvent mixture. And now we weigh the syringe with the water standard. Before we apply it into the titration cell, we apply about 1 milliliter of our standard into the titration cell. It is very important to pull back the last drop into the needle. And now we weigh the syringe back to see which weight we applied in our titration cell. We recommend to perform the Titer determination 3 to 6 times so that you have an average which you can use for the calculation, and the relative standard deviation should be below 1%, but each laboratory needs to define it for itself. Thank you for watching this video about the Titer determination. We hope this information was helpful for you.